Hey there. Yeah, this isn't too bad except for the 1/4. So let me show you what to do with that piece. So if we have 1/4 and log 16x to the 12th and then minus log x squared. Yeah, if we just get that dealt with, then we're gonna be a division problem because of the subtraction, and it'll work out okay. So this 1/4, the thing we gotta remember, this is going back to I think chapter 4. If we have the nth, that's a bad looking n, but that's supposed to be an nth root of x. That's the same thing as having x to the 1 over n. So when we see those fractional exponents, it's actually a root. So I could write that as log 1/16 x to the 12th to the 1/4, and then minus this stuff. And then I'll rewrite that 1/4 in root notation just because I think it's a little bit easier to think of this way. The 1/4 of 12 is actually great because that's just going to come out to x cubed here in a second, but we'll get there the same way here. Actually, I think this is kind of half easier to think one way and half easier to think the other way. So this and this are the same thing. So if I think of what is the 4th root of 16, so it would be 2 times 2 times 2 times 2, or 2 to the 4th makes 16, so the 4th root of 16 would be 2. So that means I can simplify that much of it down to just a 2. And then remember when we did these, we would go 4 goes into 12 3 times, so that means x cubed comes out. Or you can think of it up here as we're raising it to an exponent, which means we would multiply. So that would be 12 times a 4th, or 12 over 4, and we get the exact same cube. But I bet that's the part you had trouble with. And then let me just finish this out to be complete. I guess I should probably have parentheses around that. I'm not very good at writing those. So we have a subtraction problem, so that means it's division. So that means we have log, so if we had like log a minus log b, we have log a over b. Careful not to do log over log, because it's not that. That's our denominator. And then for this one, we can do a little tiny bit more because we have x cubed up top and x below. So if you think of that as 3 x's there and 2 x's there, we can cancel out 2 of them. So then this would simplify down after all that mess to 2x. And then that would be as simple as it can get, which I think is what we're trying to do. Yeah. Hopefully that helped. Holler if you still have a question.